Adapting the notes from lesson 5. Okay, so let's look at the definitions first. So this is actually page 8. So you write page 8 down the bottom of it. Okay, and let's look at the definitions. So radioactivity. So let's have a look. So it's the spontaneous, underline that, spontaneous disintegration of an unstable nucleus with the emission of alpha, beta, or gamma radiation. So the nucleus is unstable and it just disintegrates. Spontaneous means it happens. You don't have to do anything to it. You don't have to heat it. You don't have to hit it with neutrons, as we'll see happens otherwise. It just happens spontaneously. Okay, so we'll mark radioactivity. That's step 1. Okay, now if we go down here to mass number and atomic number, this is just revision of junior cert. Mass number, the number of protons plus neutrons in the nucleus of an atom of the element. Okay, number of protons plus neutrons, and the atomic number, the number of protons in the nucleus of an atom, an element. Okay, so remember, if you have, we'll write this in, carbon 612. Okay, so that's the atomic number, and that's the mass number. Okay, and then isotopes, we should be dealing with a lot. Atoms of the same element that have the same atomic number with different mass numbers. So they have the same number of protons, and we'll write this in, same number of protons, but different number of neutrons. Okay. Now, so we take an example. We go back to the carbon. So we've carbon. So the two most common carbons are carbon 612, carbon 614. They both have an atomic number of 6. They both have 6 protons. If something has 6 protons, it's carbon, and that's it. Okay, what changes is the number of neutrons. So carbon 612 has 6 neutrons, carbon 614 has 8 neutrons. They are isotopes. We write carbon 612 as carbon 12, and we write carbon 614 as carbon 14. You don't need to put in the atomic number because by saying carbon, that implies it has to have 6 protons, which you get from your periodic table. Okay, and then the other thing that we're going to look at here is ionization. Now, you know, an ion is a charged particle. So ionization is when a charged particle charges other neutral particles. Okay, ionization. So be aware of that as well. Okay, so that's kind of the introduction to that. Okay, if we move forward, that's page, well, we might as well write page 9 on that. Okay, and then go to page 10. And we're interested here now. We looked at the idea of alpha, beta, and gamma radiation. So let's look at the table here at the top. Sorry, this bit is right. Okay, so alpha, beta, and gamma, 3 types of radiation. Symbol alpha, beta, and gamma. So alpha is the helium nucleus, so 2 protons and 4 neutrons. Okay, beta, that's written the wrong way around, so we're going to fix that. Okay, that should be E minus 1 on the bottom and 0 on the top. Okay, and we'll come back to where that comes from. Structure, 2 protons and 2 neutrons for the alpha. So it is a helium nucleus. It is a charge of +2, so it is highly ionizing. It's got a large charge, and it is deflected in electric and magnetic fields because it has a charge. If something has a charge, it'll be moved in an electric field. Okay, as we saw with the cathode ray tube. Okay, if it doesn't have a charge, it won't. And its mass, okay, 4 units. Now, a unit here is effectively the mass of a proton or the mass of a neutron. So the mass number is 4, so it has a mass of what we call 4 units, which is very large compared to the others. If it's big, it doesn't penetrate very much. It has a short range. It won't penetrate into things very much because it's big. A beta particle, okay, electrons emitted from the nucleus, and we'll come back to that. Charge of -1, so less ionizing than alpha because it's got less charge, and it is deflected because it has a charge. It will be deflected in the opposite direction because it's got a negative rather than a positive charge. Its mass is very small. So it's 1/2000th of a unit, so about 1/2000th the mass of a proton or a neutron. So it has medium penetration, medium range compared to the alpha. And finally, gamma, high energy photons. They're photons, or high energy electromagnetic radiation. We talked EM radiation, electromagnetic. We better put that in. We'll be using EM a lot. Okay, so electromagnetic radiation. So that's kind of the wave model. That's the photon model. Charge is 0 because it's a photon. It's still ionizing because there's a high energy, so they're still ionizing, okay, even though they don't have a charge. And another error, bad thing here, not deflected. very important, not deflected in electromagnetic fields. Excuse me, because it has no charge. Okay, no mass because the photon has a high penetration and a long range, so it will penetrate a lot, as we'll see later. So there are the three types of radiation that occur in radioactivity. So we're going to mark that. They follow through. Okay, so once you have your structure and you have your charge, then the ionization or the deflection electromagnetic fields follow from that. It's not a case of learning all of this stuff. It's trying to figure it out step by step. But we'll practice that as we go on. Thanks a million.